So let's go ahead and take a look now at the key methods in the Java ReentrantReadWriteLock class. So WriteLock and ReadLock are the two key factory methods defined by the ReentrantReadWriteLock class. And you can see what they look like here. WriteLock just returns the writer lock field. ReadLock, not surprisingly, returns the reader lock field. Very, very straightforward methods. And what's interesting here is not really these methods, it's what these methods do and how they're used by applications. So the WriteLock factory method returns the writer lock, which is, of course, the lock that's used by clients when they want exclusive write access to this ReentrantReadWriteLock. And not surprisingly, again, the ReadLock factory method returns a lock that's used by the client when they want shared read-only access to the lock. These objects, of course, as we just saw, are initialized by the class constructor. Now, the locks that are actually returned by WriteLock and ReadLock implement that very simple Java lock interface that we've already seen before when we talked about Java ReentrantLock. So it's got methods like lock interruptibly, try lock, both timed and non-timed. It's got unlock, it's got new condition, and so on and so forth. And the reader-writer class semantics are enforced, of course, internally by the implementation of these different lock APIs. The methods that it provides for readers and writer locks, those methods like lock and unlock and so on, support a number of very interesting properties. So first of all, a reentrant read-write lock, as the name implies, supports recursive lock semantics or reentrant lock semantics for readers writer locks. Note that this property is not supported by Java stamped lock. And the reason it's not supported by Java stamped lock is it turns out that supporting this capability, even though it allows certain things like callbacks and object-oriented frameworks that we've talked about before as being the motivation for reentrant locks, the downside is that it's unfortunately has a fair amount of overhead. Something else that's provided by ReentrantReadWriteLock is something called lock downgrading. And this enables the atomic downgrading of a write lock to a read lock. So that means going from something that's going to be exclusive to something that will be shared, and it can be done atomically. As it turns out, this particular property and lots more is also supported by Java stamped lock. So that's someplace that they have in common. The ReentrantReadWriteLock also allows interruption of lock acquisition. So if you use the lock version as opposed to lock, let's see, it would be lock, would be uninterruptible. Then you also have lock interruptibly. So those are the two different semantics. This is also something that's supported by Java stamped lock. And then finally, there's the notion of condition support. You can actually have condition objects that are associated with Java ReentrantReadWrite locks. However, they only work for write locks, not for read locks. This property is also not supported by Java stamped lock. You can't use them in conjunction with a condition object. Now, all these features are kind of cool, but the downside is that providing all these features makes it hard for the implementation of ReentrantReadWriteLock to be very efficient, especially in comparison with Java stamped lock, as we'll see when we get a little further along. So that's the end of the overview of the key methods of Java ReentrantReadWriteLock.